This conference will now be recorded. This
Second here.
conference will now be recorded.
Okay, I think we're ready to go. Today's topic is cover crops, slugs, and naked seed. And it's kind of been rising in popularity, this topic, over the past several years, I guess you would say. And I just thought it would be another good topic that we need to cover here. And I've got to know Dr. John Tooker from Penn State University. How long ago, John, was it that you came to my farm when you started? Was that 10 or 12 years ago?
Yeah, it's in that ballpark, Steve.
Yeah, I remember right when you started working for Penn State, you were kind of doing a tour around different farms in Pennsylvania because you just new, ready to go, and I remember telling you that if you can figure out how we can manage slugs, you'll be a hero. And here we are 10 to 12 years later. And I got to say, John, I'm not sure if you're at the hero status, but you're definitely at the respected status of doing a
I'll
lot
take
of
it.
good work here over the last couple years. And so I really appreciate what the work you've done. And I'm just going to introduce John. He can share a little bit more of what actually he does. But we're fortunate, I got to tell you, here in Pennsylvania to have someone like John who is very respected in the farming community. I'll just tell everyone else about that if you don't know John. Very respected, goes to a lot of meetings and speaks and works with a lot of farmers in this topic. So with that said, John, I'm going to turn this over to you. You can go over a few of your slides, and then we'll pause. We'll talk about them. We'll have some questions and answers later on. And then I know we have some, actually one seed company represented here that actually is offering a seed that is untreated with Corey Chanko with Local Seed Company. And I want him to chime in then later on about how they as a company are responding to this. So John, if you want to, tell us a little bit more about yourself, but go right into this. Let's go over some of these slides and we'll have some questions and we'll go from there. So take it away, John.
All right, Steve, thanks a lot. And good morning, all. So we've been working with seed treatments for a while now, and it wasn't really our original goal was to kind of examine the role of seed treatments, but one of my former graduate students named Maggie Douglas kind of ran into an unexpected situation while we were trying to figure out what insects in the world eat slugs. So because there are so few chemical options to deal with slug infestations, we were starting to examine the biological role that predators could play in controlling slugs. And just by chance, or maybe a little bit better than chance, we had some treated soybean seeds in the lab, and Maggie started doing experiments with that treated soybean seed and saw that most of the predators were dying. So we thought we'd look a little bit more closely. And Maggie's research in the lab showed that neonic insecticides coated on seeds could kill the predators. And we wondered if that could happen in the field and if that was kind of relevant for field level management. And that kind of culminated in this experiment that I'm showing on this PowerPoint slide. And I apologize for not being able to share this in the kind of presenter view. For whatever reason, when I go to that, it doesn't show up on your screen. So we'll just do it in this kind of working view. But just to provide a base, we did this experiment in central Pennsylvania in one field, and we had 12 plots. That's what the black and kind of reddish checkerboard shows. The black plots where we had untreated seeds, so there was those were naked soybean seeds, and then the red orange plots received thimethoxam treated seeds. Thimethoxam is the active ingredient in Cruiser. In this case, we used Cruiser Max, and Cruiser Max has a couple fungicides in it also. So this is a pretty basic comparison. We're just going to compare slug and predator populations and plant success in these 12 plots, and whether they received an insecticide or they didn't. I assure you the fungicides aren't involved in the story I'm about to tell. I'm not going to go into that level of detail. These plots were quarter-acre plots, and we planted the soybeans on 30-inch rows so we could get down in there and sample the slugs and insect populations. And I'm just going to walk you through 4 figures that kind of tell the story. So here on the vertical axis we have yield, and on the x-axis we have soybean plants per acre. So just like you would expect, as the number of soybean plants per acre goes up as you go to the right along the x-axis, yield goes up correspondingly. But in this particular year, which was 2012, which was a really wet year, and slugs were the primary pests we had to deal with that year, the yield does not go up as much if you have the seed treatment in that field. So you can see the black dots are where we had the neonicotinoid seed treatment on our soybean seeds, and the open circles, or the white dots, is where we had untreated seeds. So on average, you can see we have more plants per acre and higher yield where we don't have the seed treatment. Again, that's because slugs were a big deal this year. And then from the next figure, we can show that slugs decrease soybean yield. And that shouldn't be too surprising from anyone that suffered from them. On the horizontal axis here, we just have number of slugs per trap. And to count slug populations, we just put white pieces of rolled roofing out in the field. So we take rolled roofing that we've cut up into 1 foot by 1 foot sections, and we just lay it in the field, and we go back and check these traps every week. So that's the x-axis. The vertical axis here is soybean plants per acre. So as the slug populations increase, so the number of slugs under our traps goes up, the number of plants per acre comes down, and of course that means your yield would come down. But here we see with the black dots, we have more slugs per acre where we have the insecticides compared to the open circles where we have no insecticides. So when we have no insecticides, we have fewer slugs, more plants per acre, which should translate to higher yield. So as I kind of indicated in my preamble there, we're very interested in building predator populations because we think predator populations can help control any insect pests or any slugs we have in our fields. And this figure starts to show that. On the vertical axis here, we have predation. So predation is just a measure of the amount eaten. In this particular case, predation is measured by putting caterpillars in the field. So we take caterpillars, we put a pin through their back end, and we put that pin into the soil. And then we visit that caterpillar occasionally to see if it's been eaten by something. So on this vertical axis, the higher number, the better. Okay. And then the x-axis is slug predators. So through our research, we've identified which predators in crop fields in central Pennsylvania are eating slugs. And to trap them, we just put these cups in the field. We sink the cups into the ground so they're flush with the soil surface, and they just fall into them as they're walking around. So again, the bigger the number, the better there. So as the number of slug predators increases, predation on those caterpillars goes up. That's a good thing. But notice the color of the dots again. Where we have insecticides, on average, we have fewer slug predators and less predation compared to where we have no insecticides. Again, the open circles where we have more slug predators and more predation. Then if we connect this to slugs, the horizontal axis in this right-hand figure shows, again, predation. That's the same number that's over on the left-hand figure, but now it's on the horizontal axis. On the vertical axis, we have the number of slugs. Again, slugs per shingle, or slugs per trap. So as our predation on those caterpillars goes up, the number of slugs in the adjacent traps comes down. That tells us 2 things. 1, that predators can control slug populations. 2, that those caterpillars that we're using to measure predation are a good proxy for slugs. In a perfect world, we would use slugs in that assay, putting the slugs on a pin, but slugs don't have exoskeletons and will pull themselves off the pin, so it's kind of challenging. But anyway, the take-home message is that you have the more predators you have, the more predation you have, the fewer slugs you have in fields. But the colors of the dots still matters. So on average, where we have no insecticide, we have more predation and fewer slugs. And where we have the insecticides, we have less predation and more slugs. So this is an example of insecticides disrupting biological control. So predators naturally occur in crop fields, but we can farm in a certain way that maximizes their populations. Insecticides do the exact opposite. They limit their population and then leave crop fields more vulnerable to pests like slugs, black cutworm, armyworm, that type of thing. But in this case, the route of exposure is different because that insecticide has been coated on the seed. That insecticide is running systemically in the plant. So now when a slug feeds on that plant, it gets a dose of the insecticide, but because it's not an insect, right? Slugs are mollusks. They're more closely related to snails or clams than they are to insects. Because they're not insects, that insecticide doesn't influence their life, their daily life. It doesn't influence their survival. They're just fine. But the insecticide is in the slug's body. And when these predators come and attack, then they get a dose of the insecticide and they can be poisoned or killed. Now, Steve, this video might work. We'll see if it does. Does that work?
It's on my computer, a little jerky, but
okay. Well, what you have there is a ground beetle,
working.
one of the things we study, and that ground beetle recently ate a slug that was feeding on an untreated seed, plant from an untreated seed. That beetle is recently ate a slug that was feeding on a soybean seed that was grown with an insecticide on it. This one too. So these beetles show clear signs of neurotoxicity because they're getting a dose of insecticide from the slugs they just attacked. So in our experiments, there's no way for the insecticide to get to the beetle unless it comes through the slug. And this is just kind of video evidence that that insecticide messes up these beetles. And here's an example of a slug that survived the interaction with the ground beetle, but the slug is alive, but the beetle has been poisoned. So it's just a little video evidence that indeed these beetles are getting messed up by the insecticide flowing through the slug.
So, John, can I just pause right there? I got a question. Did I understand you to say that our friendly predator beetle doesn't even have to kill the slug to potentially receive a toxic dose?
Yeah, that's right. We have some evidence suggesting that. So that one little video clip shows probably a slug that just got attacked by like one mouthful. Sorry, a beetle that attacked a slug and just got like one mouthful of slug tissue.
Yep.
And there was enough insecticide in there to mess that beetle up.
Okay, that's a new one. I never heard that one before.
Yeah, they don't need to eat the whole thing.
Okay.
Oh, there's just one other connection to insecticide use in slugs. So in 2017, this study came out, and I know that figure is kind of too small to really see. But the bottom line is that this figure shows on the vertical axis slug abundance, and the x-axis is just time, various points in the years, for two different insecticide and a control. So the purple line is the one to focus on. You can see that purple line is slightly higher than the other two. That purple line is the slug population where growers are using chlorpyrifos or Lorsban in Australia. So on average in this experiment, you were having more slugs where farmers are using Lorsban broadcast across the entire field. So in this case, this is happening because the Lorsban is directly restricting predator populations. The insecticide isn't flowing through the slug or anything like that. This is just direct exposure, and as you spray across the field, you'll kill a lot of those ground beetles. So it's the same idea, slightly different mechanism, whether the insecticide is applied as a seed treatment or is broadcast across the field. So my message is simply this: manage for the pests that you have. Insecticides can make some pest populations worse. That is clear with our slug data. It's also clear for spider mites. So spider mites are worse on insecticide-treated plants. So if you don't have pests to worry about, my main stance is don't use insecticides. If you have slugs, insecticides aren't doing a darn thing for you, so get them out of the field. So Steve, that's kind of the main message. If you want me to continue into that project where we have evidence that predators can make a difference, I'm happy to do so, but I can take questions now or whatever you want.
Yeah. Let's pause a little bit for questions. I'm sure there's some questions out there. Everybody's mic on. So who has the first question for Dr. Tooker? Who has the first question for Dr. Tooker? Anybody? No questions yet? Okay, John, why don't you wrap up? Then I'm going to have a few more questions. If you want to do that now, let's just go ahead and tell us about your project, and then we'll open up for questions again.
Okay, that's fine. So for a while at Penn State, we've had something called the Diversified Dairy Cropping Systems Project, and this is kind of an innovative experiment led by an agronomist named Heather Karsten. And Heather has, we've been pulling this experiment off, led by Heather, for about 10 years now. And the main detail of it from an insect and slug management perspective is that we have two rotations that are quite different. One is a very simple 2-year kind of just a corn soybean rotation that has no cover crops. And then we have these 6-year rotations that have cover crops, alfalfa, corn, and small grains in them. And that's the basis of these rotations are fairly simple because we know the longer the rotation, the fewer the pest challenges. But from an insect and slug management perspective, these rotations are different because in the short, kind of simplified rotation, we're using BT corn. The corn and the soybeans both have seed treatments, and we're putting a broadcast application of pyrethroids out after planting, like a lot of growers do. But in the more diverse rotations, we're just using IPM. So I have a graduate student that scouts those plots every week, and if there are any insect pest populations out, we'll quantify that population, and if it's a big enough population, we'll use an insecticide. But notably, the pests have been worse in the simplified corn soybean rotation where we're using preventative pest management tactics. So this is the opposite of what most people expect. Because you're paying money for those preventative tactics, you would expect your pest population to be lower, but in fact they're worse, and our evidence shows that they're worse because of predator populations. Now, these data here on the top panel show 6 years of information. So on the vertical axis here, we have slug predators per trap per day. And again, to capture predators, we just sink these cups into the ground and we go out and we count the predators. And then we have 6 panels going horizontally. On the left with the gray circles, that's the simplified rotation. So that's the high input preventative rotation. And the black dots show the low input IPM-based rotation. And again, these dots are showing the predator population. So over the first 6 years of the experiment, you can see that the predator populations kind of slowly start to diverge. But it's not until the 4th year that it really kicks in. So the first year, the 2nd year, and the 3rd year, the predator populations are about equal between these two rotations. But the 4th year, the 5th year, and the 6th year is where we see the predator populations grow greater in that low input, high diversity rotation. And then the panel at the bottom shows slug damage to plants, and we relate that to those early season predator populations. So as early season predators go up, slug damage comes down. So together this provides information that if we can farm with the predators in mind, they're going to help manage our pest populations. And as an advocate for IPM, I'm not asking for growers to totally ignore chemicals or insecticides. I'm just asking them to scrutinize their use and just use them when necessary. And this top panel shows that if we can do that continually for 4 years, then our predator populations really start to kick in and they become allies in pest control. We don't need as much reliance on insecticides. All right, Steve, that's kind of the basics of the story, and I'm happy to have the conversation without slides from here on.
Well done, John. Yeah, well done. And I have two comments here on the chat on the side. One is a question from Dan from Indiana. And by the way, Dan, it was good to meet you last week. Dan Ross from the NRCS. But the question Dan has is, can a beetle absorb enough toxin by simply walking through a slime trail of a slug? So what do you say to that, John, Dr. John?
Sure, Dan, we don't think that's the case. So, and this might be more information than you need to know about slugs, but slugs have 2 types of mucus. They have a mucus that kind of lubricates their path. So that's their locomotory mucus, and then they have a defensive mucus that is on their back, kind of the rest of the body. We have a little bit of evidence that the slime can occur in the defensive mucus, but we have no evidence to suggest that it's in the locomotory mucus. But our best interpretation of the data we have is that slugs get this slime when they get a mouthful of, slugs get the insecticide when they get a mouthful of slug, and we're not so sure that it can completely be conveyed only by the mucus. But we haven't really investigated mucus as much as we can.
So that's a great explanation. So locomotory mucus, new word for me. I like that word, John. I'm going to try to use that to impress people sometime. So here's another question from Andy. Andy comes from Southern Alberta. Any evidence for this kind of response in other crops on other predators? And his context is Western Canada. We've used neonics on canola for flea beetles and with peas for the pea leaf weevil. With the pea leaf weevil and one species of flea beetle. Okay, the neonic only stuns the pest and kind of slows it down. Extra easy for a predator to catch a toxic last meal. So I guess, have you heard about any other species, any other crops that we typically have here in Pennsylvania that you could apply this to? What you've learned so far, John?
Yeah, so in response to Andy's question, so Andy, one of the key points of this study with slugs is that they're mollusks, right? So they are not susceptible to the insecticides. So if they get a dose of the insecticide in their body, they live normally. In your example with canola, some of those insect pests, maybe pea leaf weevil or flea beetles, they would be susceptible to the insecticide. So they are likely to be dying in response to the insecticide before a predator can get to them. That said, we don't know what happens if there's a dead insect and it has a good dose of the insecticide in it, and then some scavenger comes along and scavenges the dead insect. That would likely be problematic for the predator populations, but a lot of predators kind of avoid that type of scavenging. The one exception to what I just said there is if you have resistant insects. So if you have insects, say flea beetles or pea flea weevils, that are resistant to the neonicotinoid, they could have it in their body and it just isn't affecting them. And then if a predator attacks, they could get a dose of it. So that's an exception when we have resistance. In terms of, is this happening in other crops? Yeah, we know it's happening in corn. We know it's happening in soybeans. I'd be surprised if it wasn't happening in canola. We've done some studies by taking data from other studies. So this is called a meta-analysis. So you take the analyses from other studies and you kind of throw them all together in this big database. And we found that kind of on average across North America, where you have a seed treatment, you have 15 to 20% fewer predators compared to where you do have a seed treatment. So generally speaking, these neonicotinoids are simplifying our predator communities. And it may not sound like a lot. So if we have 20% fewer predators, that may not sound like a big deal. But our research shows it is a big deal. And just as a quick example, if there was a game between the Pittsburgh Steelers and the Dallas Cowboys, and the Steelers had 20% fewer players on the field, who's going to win that game? Right? Unfortunately, it might be the Cowboys. I don't know who likes the Cowboys, so that's easy to beat on them. But the point is simply that fewer predators isn't doing you much good. More predators does you good.
That's a great example, great explanation. One more question here, then we're going to open up for anybody. Joel asks, how effective would strip cropping corn and soybeans? And I'm assuming that means kind of like small sets of rows, every other one or whatever, about accelerating an ecosystem balance of the predator to prey ratio. Is that enough, just corn and soybeans, to help out, more predators?
Sure. Joel, I like the way you think. We actually have an experiment in the ground, well, not right now, but for the past couple of years, looking at this very thing. So we expect that if you increase crop species diversity within a field, then your predator diversity is going to increase too. So we've been mixing corn and soybeans together without strips. and seeing how they fare that way. We're doing that within a kind of a dairy silage system, and then we'll just harvest the whole thing. But we're finding that there are more predators when you have two crop species compared to when you just have one. So the predators respond to kind of that diversity in form, because corn and soybeans are quite kind of different shaped. They have different architecture, and they also respond to that diversity in space. So just having different crops in the same field can be really valuable. And just to be clear, there's a good relationship, or a well understood relationship, between plant species diversity and arthropod diversity. So arthropods are more or less insects and spiders together. So if you increase plant species diversity, you actually increase arthropod diversity, but the predators come too, and the predators usually win. And if you get a good predator population, they'll keep the plant feeding insect populations down. So I like that idea, Joel.
Okay, questions from any of you? What questions do you have for Dr. Tucker here today on this topic?
This is Lloyd. What about planting green? Any effects one way or the other?
Yes, Lloyd, indeed. So we've done a little bit of work on planting green with a couple of collaborating farmers here in Pennsylvania. And our evidence suggests that if you plant green, you will get a benefit. You'll get two or three benefits in terms of pest control. One is that the dying cover crop. So I'm assuming you plant green, and then 1 to 7 days later you hit the cover crop with glyphosate, right?
Yeah.
So we're finding that dying cover crop, killed by glyphosate, so it kills slowly, actually becomes more attractive to slugs than the emerging cash crop. And we think that mechanism has something to do with the protein content of the dying cover crop. So protein is more available from the dying cereal rye than it is in the growing cash crop, so either the corn or the soybean. On the same point that I made earlier, then that more diverse planting, when you have the dying cover crop and you have the emerging cash crop, that's higher plant species diversity. You'll get more predators there. So yes, we see strong evidence that planting green can help, but I must be frank, we've seen some disasters coming with people that plant green because they maintain their standard insecticide regimen. The best success that I've seen is folks that are using untreated seed. They're not putting an insecticide in with their burn down application, either pre-planting or post-planting, but just using IPM to understand if pest populations arise. And Lloyd, just to be clear, when people are planting green, they're at a higher risk for some insect pest infestations, particularly armyworm and black cutworm, which you've probably heard about. But I'm not asking folks to leave themselves vulnerable to those pests. So rather than using preventative treatments, the goal here is to use an untreated seed and not put an insecticide in with the burn down, because you're going to be scouting those fields regularly. And if you find armyworms or black cutworms, then you can put out a rescue application. But most years you're not going to need that, because most years those pests don't show. They're kind of an intermittent problem. Does that make sense, Lloyd?
Yeah, I had to do my mic.
No problem. No problem. Just want to make sure.
Yep.
Yeah, makes sense.
Good. That sounds great. One more question, and then I'm going to ask Corey Chelko, who works with Local Seed, and they supply naked seed. So one more question, and then we're going to go to Corey. So get ready, Corey. Who else has a question before that?
Steve, Dan Towery.
Okay, go ahead, Dan Towery. Go ahead.
I was curious with the seed treatment. What about on fields that have been tilled? Is it actually pay to have it on?
Dan, so all the research that we've done is in no-till fields. Pennsylvania is primarily a no-till state, and that's where we're based. So we haven't had the opportunity really to do tilled work. But I would say the same thing. Generally speaking, the insects that are being targeted by the insecticide coated on the seeds are uncommon. Generally speaking, they're called secondary pests. So if we're dealing with secondary pests, they're not our primary concern. So if you're regularly using seed treatments, I would encourage you to find a field where you can experiment. Maybe put a small field in naked seed and see how you do. Assess your own local populations, and you can kind of make these decisions from an informed perspective rather than an uninformed perspective. I'll also say, Dan, that there's one kind of main insect pest to worry about in a tilled system if you're using cover crops, and that is the seed corn maggot. And the seed treatments do a great job against seed corn maggot. But seed corn maggots are a pest of tilled ground, particularly when you're incorporating the cover crop. So if that's your main concern, because you do that regularly, then the seed treatment may have some value. I would still recommend that you find out for yourself. So rather than guessing of whether the insecticide is paying for itself, do a small experiment on a side field to find out for yourself.
Okay, Corey, you ready to share a little bit how you as a seed company have responded to this? I'll just set this up a little bit, that this whole, you hear a talk like this and you're like, well, yeah, I'd like to get some naked seed, and you talk to your seed salesman, and they look at you like, what are you thinking? We don't do that. We won't do that. And I will say it to this point, pretty much the larger national seed companies have not offered this service. But Corey, you're located here in Pennsylvania. I just full disclaimer, I work with Corey and what used to be TA Seeds, now Local Seeds. So how have you responded to this naked seed demand?
So we do offer a wide variety of corn, soybeans, and actually most of our seeds available as a naked product. And I want to speak to why some of the multinationals don't offer some of this. It's really simple. Inventory control. I just did some quick math. I know myself and John have had these conversations in the past as well. Right now, we offer about 73 different soybean varieties with 6 different treatments, and it comes in 4 package types. It means we have 1,752 different soybean choices to manage and deliver. That's all of a sudden, when you become a multinational corporation, that even jumps higher. And the same thing could be said on corn. So we do try to simplify it and target some of the seeds that we have good vigor, a good supply, good germination, all the things that a potential fungicide or insecticide treatment might put a Band-Aid on. And we try to target the specific lots to be naked that are of a really high quality, so we don't have as many issues that the fungicide insecticide treatment might help prevent. So the biggest thing I have to say with working with your seed supplier and even ourselves is, if you are interested in doing this, the time to start having these conversations is actually in the summer, because once the treatment is applied, it's impossible to get off. But most folks would be willing to at least entertain your scientific experiment if their plant's set up that they can divert some of the seed prior to it being treated.
That's a great answer, Corey, and I appreciate that. I see Cody Beacom's on as well. I know, Cody, I think you're involved in some of the seed business. Just, is there anything you want to respond here from what you're seeing out there from the seed sales side? I don't know if you have a microphone or not, Cody, but if not, that's fine. Anybody else have a question for John or comment about anything? I have a couple questions here we can talk about, but want to give you guys a chance here. What are some more questions? Who has tried this? Who has done this? Or do you know of people who have tried it? Are you working with people who have tried it? What has their success been? Anyone? Well, I'll just say that I've tried it for several years, and working with some of John's team here in Pennsylvania. And frankly, I have not seen a negative effect. I do scout. I think I probably scout my fields a little bit more because I am worried. I am concerned, like you said, John. you kind of feel a little bit unprotected, but so far, so good. A question I want to get back to you, Dr. John Tooker, is when does a farmer earn the right to plant naked seed? When is a time, maybe I could say it another way, that you shouldn't do it? Or what's the process here to want to do this?
So I guess I would say a farmer earns the right just by being a farmer. I mean, just because
Okay.
the industry restricts your choice doesn't mean that you have to go with the flow. I'd say be a thorn in your seed supplier's butt and encourage them to give you some untreated seed. But more practically, you guys all know your fields better than anybody else. And if you've been farming a certain rotation for the last decade or so, and you rarely see an insect pest population, those are the perfect rotations to try this in first. Because you've been using a treated seed, your pest population is going to be low. Your predator population is also going to be low, but fortunately, insecticides control insect pests, right? So it's not the insecticides don't work, it's that the pests tend to be rare. They're going to be even more rare in that rotation where you've been using insecticides regularly. So my feeling is that if you have been doing this, or you're putting pyrethroids out generally as a broadcast each season, that the pest pressure is likely to be even lower, and there's not as much risk as you might perceive. So start small, see if you can do it in a side field, and not commit too many resources to it, but scout that thing regularly, and just satisfy your own curiosity is if this is something that can work in your realm.
Okay, here's a question. So you have a large scale farmer. He likes to be the first one in the neighborhood planting corn, pushing a little bit, colder soils. What about just getting a fungicide on and no insecticide? Any comment on that?
Yeah, I think that's a great way to start. We have data that the neonic insecticides aren't doing all they're advertised to do. We have no data, similar data on fungicides, and I'm not a plant pathologist, but the evidence that I've seen suggests that the fungicide provides more value than the insecticide. So if you can go fungicide only, it's a great place to start.
Okay, fair enough. Okay, other questions from anybody? Today's your chance to ask these questions. Other questions from anybody?
Steve, there's a question from Andy there about any seed I can get naked, I do. The only thing I can't is corn, sunflowers, and canola. Hopefully that will change soon.
Oh.
And so that's a good observation, Andy. But I also say that squeaky wheel gets the grease here. If you can talk to your regular seed dealer and kind of push a little bit more, or even go to a local person. So we get our untreated seeds from Corey here at Local Seeds. That's kind of an inadvertent advertisement if you're in Pennsylvania. But they've been really easy to work with, and they have kind of the products we're looking for. Even corn, though our choice can be a little bit restricted, they've been able to satisfy what we need. So Andy, if you have a local guy wherever you are, I bet they'd be happy to try to satisfy your request.
Okay, other
Steve,
questions? Yeah, go ahead, Dan.
Dan, maybe want to talk a little bit about the need to order early to get naked seed.
Yeah, without question.
Yeah, go ahead, John.
Without question, I've found that the people that have the most success plan early, and they make their request early. So Corey can talk to this a little better than I can, but the early in my mind is we're like talking September, October. So the couple times that I've gotten Corey my order for our next research season in like August even or September, he gives me a email response with a lot of exclamation points because it just makes his life easier.
So I'll chime in.
Go ahead, Corey.
We run a farming and processing facility for seed corn. Typically, here in Central PA, we're wrapped up with harvest around mid-October. As soon as that process is done, we move into sizing and treating seed. And as of today, we are still sizing and treating soybeans. So if we were to have the ability to treat upon demand, that would be awesome. But in reality, it takes us about 5 to 6 months in order to process and package everything. So we kind of have to plan ahead And when it comes down to what we have available in the warehouse, the earlier we know, hey, I definitely need some untreated, we can set that aside and make a plan to do it. After the fact, it's hard for us to go back and treat small lots. So we try to get the bulk of it planned out early in the season, simply so we can actually deliver and be on time for our customers.
Corey, just a question. You may not want to answer this, but real roughly, how many acres of untreated seed do you think is out there, like for 2019? It's going to go in the ground.
The majority of ours actually goes for organic or transition to organic operations. As for BT or different glyphosate tolerant or Roundup, it's a small percentage, but it is growing, especially in areas where guys are restricted, such as wildlife refuges, different national parks, army depots. Some of them are ecological areas that don't allow insecticides. So guys are starting to have the experience and move it on to other aspects of their operation where they're not restricted because they do see benefits.
Okay, other questions from any of you? Other questions? David?
Yeah, Steve, it's actually kind of two-part, really. So some of the seed companies here in Illinois are telling their growers that if they are, that they will not give that grower any replant if they order and plant untreated seed from them. So that's kind of been one of the challenges. You know, it's kind of like, are they selling genetics or are they selling seed treatments? So that's what and then another thing, this winter I'd actually seen a picture, and I think it was down in southern Illinois, where a farmer had split a planter with seed that was treated versus seed that was not treated, and the slugs basically attacked the treated seed and left the untreated seed alone. Didn't know if John, if you'd seen any of that type of evidence or not.
Well, David, I've heard of that picture from Southern Illinois. I haven't seen it with my own eyes yet, but I've heard of it. And my guess would be that it's a predator population. I can't figure out why slugs wouldn't want to eat an untreated seed. I mean, they like plants after all. But so my feeling is that would be a predator-driven thing. I don't know what else I don't know what else it could be. And on the incentive side, you're quite right, and that's some of the pushback that I've gotten from growers that are curious. But if your seed dealer is saying we're going to give you a full replant if something goes wrong if you use a treated seed, that's a pretty strong incentive to try. So that's why I tell folks that if you want to do this, you have to be forthright and you have to tell the seed dealer, like, this is how it's going to be. I'm going to buy untreated seed from you, or I'm going to buy untreated seed from the guy down the road. So if you want my business, you got to do it. And I can't really argue very well against those incentives because it's pretty encouraging. I mean, it's pretty nice incentive, right? But another thing to keep in mind is that a lot of people are doing cover crops because they're valuing kind of soil quality and they're trying to build soil health. These pesticides are not helping you build soil health. They're not helping you with your soil quality. We have some experiments in the ground that we're trying to quantify the effect of insecticides. We haven't gotten there yet. We're kind of still a work in progress. But if you think about it from that perspective, that might be the incentive you need. So if you're really keen on soil quality, then pesticide use is kind of counteracting. Our best hypothesis is that pesticide use is counteracting your efforts.
Okay, great answer. Go ahead, David. Did you have a follow-up?
Oh, I was just going to say I couldn't agree more with that.
All right. Okay, I think Mike was going to say something. I think so. Mike, were you going to say something? Then we'll go to Lloyd.
Correct. I just have a comment that where I found some naked seed like last week, I looked up Blue Dasher Farms. It's a research farm, and they had a list of companies that they work with or listed that they work with naked seeds. So I was able to find some corn seed last week. I bought enough to do 20 acres of
Mm-hmm.
corn seed. So, just a
Yeah,
comment.
and I'll just make a comment. It's Jonathan Ludgren with Blue Dasher Farm out there in, I believe, southeastern South Dakota. I think it's where he's located, doing a lot of work with, he's an entomologist too. I guess I know, John, you've probably ran across him a time or two. But as Mike kind of alluded to, and Corey alluded to, you can get naked seed that's organic, and a lot of times the price of that is significantly higher because it's organic, and you may not have the genetics you want. So that's just a little bit of a FYI on that, I guess. So Lloyd, back to you. You were going to say something.
No, I was going to ask Corey, if you're not putting the treatment on the seed, is it much cheaper? I mean, is there an incentive to go out and try naked seed, in your risk management style?
Actually, at this point in time, we don't discount it because it's a different step for us. It's actually a little bit more work for our processing plant to do it. So kind of what we would save based on the treatment, it takes that much more effort on our bagging line. So at this point in time, we don't offer a discount. I imagine there is some companies that might have a little bit different style processing plant that may be able to do that.
Good answer. Another question or two here. Other questions? Anybody here this morning? Okay. Well, I want to thank everybody who has tuned in today, and I thank you too, John Tooker, for taking the time. Really appreciate that. I did want to mention that next week we have a special guest as well, and this is a little different twist here on anybody I've ever interviewed, but it's Rowan Atwood, who is the Director of Sustainability for Wrangler Jeans. And those of you who have been following on our webinars here and have heard me speak, have heard me mention Wrangler Jeans and how they as a company are really actively focusing on trying to get their cotton farmers to use cover crops and soil health and so forth. So I have met Rowan a couple times. We've talked, we've communicated, and he's just well-spoken. But this is going to be a unique time next Monday. I had to do it Monday because of some other scheduling conflicts. So next Monday we're going to have an interview with Rowan Atwood of Wrangler Jeans. So that's exciting. So yeah, thanks for everybody who joined today. Again, thank you, John, and wish everybody have a good week. We'll see you next week. Thanks a lot for attending today, and thanks again, John.
Thanks, Steve. No problem.
Yep.